Hi everyone, in this part of the course we would like to discuss the induction machines. So in our first lecture we would like to discuss the importance of induction machines and the construction of induction machines. So first, what is the importance of induction machines? The induction machines are wound rotor type or the wound rotor motor types are suitable for loads requiring high starting torque and a low starting current. So simply there are two types of induction machines which we are going to discuss in this video. We have something which is called the wound rotor or the slip ring, and another type called the squirrel cage. So the wound rotor type motors we can obtain from them high starting torque and low starting current, as we will learn inside the course. The induction motors can be used for the loads that require speed control. You will find that in induction machines or induction motors, which is the widely used motors, you will find that we use it for loads that require speed control. We have different methods of speed control inside the induction motors, which we are going, of course, to discuss. The induction motors are used in cranes, pumps, elevators, and compressors. The induction generators can be used with wind turbines because they have a variable frequency or a variable speed, so we use with them induction generator. The induction generator have or require less maintenance because of its robust construction. Or, for example, if we are talking about the squirrel cage, as we would see, it does not require any maintenance because it does not contain brushes, unlike the DC motor. The squirrel cage motor is used as induction generator, as is also it is cheaper in comparison with the wound rotor. And of course, it requires less maintenance, and we will understand why in the construction itself. The induction generator also does not require any synchronization conditions, unlike the synchronous motor and synchronous generator, because the induction generator itself takes the excitation from the grid. Okay, so the grid or the excitation is provided from the grid, so the induction generator automatically synchronizes with the grid. Also, we are going to discuss the induction generator. The induction generator, as we said, it is used in wind farms or wind turbines in order to generate electricity. So, the induction machines in general or the induction motors specifically used for loads that require speed control, wide speed control methods. The induction motors are used, of course, in case of requiring high starting torque and low starting current by using the wound rotor or the slip ring types, and the induction generator used inside the wind farms, which have since the wind have a variable speed, so we use the induction generator in order to produce the voltage or the output voltage same as the grid. Okay, but if we use a synchronous generator, it will produce a variable frequency output, which is of course not acceptable. That's why variable speed source is used with induction generator. So in order to understand about the induction machine, we need to understand the construction of induction machines. The induction machines, similar to the previous machines, consisting of stator, rotor, and air gap. Okay, three main parts. Same as the synchronous machine, we have the field winding and the armature winding in DC machines, and we have in another type, which is the synchronous machines, of course, stator, rotor, and air gap, similar to each other. All of them are based on the same principle of electromagnetic induction. So first, let's understand the stator. A stator first is the part here which contains the winding or the three-phase winding. Okay, the stator three-phase winding. So simply it has a cylindrical shape. You will find it is a form of cylinder. Okay. Number 2, it is laminated, of course, to reduce the eddy losses, as we said before in the DC machines. And it carries a 3-phase balanced winding. You will find that here we have A, and B, and C. Okay, 3-phase winding, A, B, and C. And A, for example, it will be like this, going in like this, and B going like this. Okay, you will find that we have input and output, of course. And C, for example, like this. Okay, going to the positive or going to the C dash. Okay, whatever it is. So the 3-phase winding are shifted by 120-degree electrical in space. So what I mean by this, you will find that the angle between A and B, and the angle between B and C, angle between C and A are 120 degree. Okay, between this angle is 120 degree, this angle is 120 degree, this angle is 120 degree, and this one have C is a phase winding, B is another phase, and C is another phase, because you know that in electrical power system we use a 3-phase system. Okay, there are of course single phase induction machines, but now in this course we discuss the 3-phase induction machines, which require of course high power. The stator can be connected in delta or star, so the winding itself can be in the form of delta, for example, like this. Okay, the delta connection, this is the 3-phase winding, or can be in a star connection like this. Okay, we will also discuss the equivalent circuit in the next video. Like this, it can be a star connection where we have A, B, C. A, B, C is a 3-phase input supply and 3-phase input supply. So in case of the motor, we supply the 3-phase voltage to the stator. Okay, in case of what? In case we are talking about a induction motor. In case of a motor, we provide the 3-phase here. In case of a generator, we take the power from the 3-phase of the stator. So the stator acts as if it is the armature winding in the DC machines. Second thing, of course, there is air gap. Air gap, this is the rotor and this is the stator. Between the stator and rotor, of course, we have air gap. And as we said before, this air gap is responsible for a few functions. Number 1, a very small clearance to allow the rotor to rotate. Okay, because if there is no air gap, then this rotor will have a friction with the stator, and of course this is not allowable. So we need a small air gap or a small clearance to have a small X or the small reactance in the equivalent circuit. So this small gap allows the rotor to rotate. Another thing is that air gap allows for electromechanical conversion or the electromagnetic conversion. They convert the electrical energy into magnetic, then magnetic to the electrical here, magnetic to electrical on the rotor, then the rotor or the electrical power will be converted to mechanical. Whatever it is used for conversion or the conversion of electric power or the energy occurs inside this. Of course, it is responsible for cooling the machine. Now the third component is the rotor. The rotor here consisting of, number 1, it is cylindrical and laminated. Okay, cylindrical, same as the stator. Okay, laminated too, in order to reduce the eddy losses. It carries the rotor winding. So this rotor carries a 3-phase winding, or it can be copper bars. This is depending on type of rotor, as we will discuss now. So it can be the rotor itself can contain a 3-phase or can contain copper bars. The rotor can have two types, one which is the wound type or the slip ring type, and the other type is called the squirrel cage. Now the first type of the rotors is called the wound rotor or the slip ring. You will find that wound, what does a wound mean? It means that it is wounded. Okay, you'll see that here the wires is wounded around the rotor. So this one is a 3-phase winding. You will find that it carries the rotor winding, which in this case a 3-phase winding, same as the stator. Okay, so we have in induction machine, the stator is a 3-phase stator, 3-phase winding, shifted by 120 degree in space, and the input supply also shifted by 120 degree electrical. So it has two characteristics. The first thing is that the stator is shifted by 120 degrees as in space or mechanically, and 120 degree electrical according to the supply. Here the winding is also a 3-phase winding in case of the wound rotor or a slip ring, and these windings are shifted by 120 degree also in space. So it has a 3-phase winding shifted by 120 degree. It can of course be star or delta, but in general they use star. The rotor winding is short circuit by means of a slip rings. So the 3-phase input supply or the stator is not a short circuit. It is provided by a power or connected to a 3-phase supply, or we take it the output in case of the induction generator. But in case of the rotor winding is short circuit by means of slip rings and brushes. So find here we have the 3-phase winding are short circuit together. All of them are connected together as a short circuit by the means of slip rings and brushes. Since the rotor is rotating, so we have brushes in order to connect with the slip rings. So let's look at here. You'll find here this one is a ring, this one is a ring, and this one is a ring. And you'll find here the brushes 1 and 2 and 3. Okay, so we have 3 brushes connected to the ring which is rotating, each of this ring representing one of the phases. So by connecting it like this, they are short circuit together. Okay, now the advantage of this type of slip rings is that we can add here a variable resistance. Okay, so what is the benefit of this resistance? This resistance is helpful in speed control and starting of machine, as we will discuss in the next lectures of the starting methods and the speed control. The rotor winding, as we said now, is accessible, which means that we can add resistance for speed control and starting of the machine. The second type of the rotor is the squirrel cage. You'll find that it looks like this. This is our rotor. Our rotor is consisting of conducting bars are placed in the rotor slots. So this is considered as the slots inside the rotor, and you'll find here copper bars are inserted in the slots. This one is rotating. You'll find that it's called a squirrel cage because it looks like the cage where the squirrel is put here, as you know that the squirrel keeps running inside the cage. So this cage looks like the squirrel cage. That's why it's called a squirrel cage rotor. Okay, if we look at this in the elevation view, you'll find here that these bars are short circuit by a ring. Okay, here and here. The bars are short circuit at both ends by aluminum or copper rings, okay, to make the short circuit between these copper bars, okay, similar to the 3-phase winding in case of the wound rotor are short circuit together. Now, before we end this lecture, we need to understand the principle of operation of the induction motor. So we said that the induction motor is consisting of the generator, whatever, both of them are on the same principle, but the most important now is the induction motor. So we have the three-phase input supply to the three-phase of the stator. And we have here, in case of the wound rotor, we have a three-phase in the rotor itself, shifted by 120 degree, shifted by 120 degree. And the rotor is short circuit with each other. Okay, so how does the induction motor operate? First, when a three-phase balanced supply is applied to the stator winding. So we have here V1, V2, and of course V3 between CA, the three-phase balanced one, or VA, VB, VC, whatever. We are talking about phase or line, whatever we are talking about now, three-phase balanced supply. So this will cause a three-phase balanced current. Three-phase supply causes a three-phase balanced current, IA, IP, IC. The three currents are shifted by 120 degree. Why? Because the supply itself is shifted by 120 degree. Now, since the three phase are shifted in space by 120 degree, what will happen? These three currents will produce a phenomena in the induction motor, same as the synchronous generator. What is this phenomena? The three-phase balanced currents produce a rotating magnetic field at a speed of synchronous speed, which depends on the frequency of supply. Okay, so this produces a rotating magnetic field having the same speed of the synchronous speed. So the speed, as you remember, ns, or N speed, is equal to 60 F, or 60, let's write it, F over B. Okay, so the speed of the rotating field is dependent on the frequency of the supply. Okay, so it depends on the frequency of supply and rotates at a synchronous speed. So the rotating magnetic field here, due to the presence of a three-phase balanced supply shifted by 120 degree, this rotating field will cut the rotor. So the rotating magnetic field will cut the rotor, which will cause induced EMF inside it. So it produces a three-phase induced EMF. Okay, three-phase balanced EMF. Okay, since the rotor is short circuit, therefore a three balanced or three-phase balanced currents will be produced. Okay, since it's short circuit and we have voltage here, induced voltage here, another one here, and another one here, so three-phase balanced supply is produced. Okay, so the three-phase balanced currents here will do the same as the three-phase balanced currents here. The three currents here produced a rotating magnetic field. These three currents will also produce a rotating magnetic field. So what will happen? The three phase here, rotating magnetic field, and another one here. The interaction between the two magnetic fields will produce a torque inside the machine. So the torque is produced due to interaction between these two rotating fields. So again, we put a three-phase supply here. Three-phase balanced supply causes a three-phase currents. The three-phase currents produced a rotating magnetic field. The rotating magnetic field cuts the rotor. So what will happen? It will produce a three-phase induced voltage. The three-phase induced voltage produces three-phase currents. The three-phase currents will produce another rotating magnetic field. So we have here, for example, as if this one was a magnet and this was a magnet, but this magnet is rotating. Okay, The magnetic field is like a rotating magnetic field is like a magnet rotating. So this magnet is rotating, this one is rotating, so the interaction between them will cause the rotor to start to rotate or produce a torque inside the motor. Now we need to understand the frequency of the EMF induced inside this rotor. So first, at starting, the speed of the rotor in R is equal to 0. So the MS or the stator fields cuts the rotor with a speed of ns. We said that the stator field having a frequency equal to the supply frequency of ns. Okay? So the ms cuts the rotor with a speed of ns. So the induced EMF inside the rotor will have the same frequency of supply, which is ns. Now the torque is produced as we said before, and the speed nr starts to increase. So what happened in this case? This one, the rotating magnetic field like this, for example, will have a speed of ns, and the rotor itself rotate with nr. Okay, after torque is produced. So what will happen? ns and nr. So what is now the frequency of cutting? The frequency of cutting, what does it mean? It means that the rate at which this field cuts the rotor. What is the relative speed of cutting? As a speed nr, at any speed nr, the ms or the field here cuts the rotor with a relative speed of ns minus nr. Okay, at the beginning when nr was 0, so the rotating field cuts the rotor with a rate of ns. But now when the rotor starts to rotate, then the relative speed between them is ns minus nr, or the induced EMF here will have a frequency depending on the relative speed. So in this case, the EMF of the rotor has a frequency f2. f2, we said that the frequency is equal to np over 60. But the speed here will be the relative speed because it depends on the rate of cutting. So it will be ns minus nr. So if I multiplied here by ns and multiplied here by ns, so what will happen? We will have p ns over 60. So what is p over 60 ns? Is the frequency f1 or the supply frequency. And we'll have ns minus nr over ns, ns minus nr over ns. Now this is known inside the induction machine as the slip. So the frequency of the rotor or the frequency of the voltage induced here is sf1, where s is ns minus nr over ns. So now the relation between them was sf1, between f2 and f1. Now what is the speed of mr of the rotating field of the rotor? Here mr, what is its relative speed with respect to rotor? Okay, remember something here which is really important, that the field ms and the field mr, both of them have the same speed, which is the ns or the synchronous speed. So the speed of mr, which is ns, with respect to the speed of rotor is what? Is ns minus nr. Okay, so that is the speed of mr or the rotating field here inside the rotor with respect to the rotor. Okay, since it has the speed of ns and rotor have nr. So what is the relative speed of mr with respect to the stator? Okay, it will be ns, which is the speed of the mr minus the speed of the stator. Stator is stationary, so the speed of it is 0. So the relative speed of mr with respect to the stator is simply ns. So the question is, can the rotor run at ns? Can the rotor speed reach ns? The Answer is no. Why? Because if the rotor rotates at ns, so look at the rotating field. Rotating field of the stator is rotating at ns, and the rotor is rotating at also ns. Okay, if we assume this one rotates at ns, this one rotates at ns. So what will happen in this case? You will find that the rotor, for example, this point, will see the rotating field as if it is a constant field. Why? Because both of them are rotating at same speed. So the rotor will appear stationary to ms, as if both of them are rotating at same speed, or both of them are stationary. Okay, they are stationary, not moving. So in this case, what will happen? No EMF will be induced. So no EMF means that no currents will be produced, no rotating magnetic field of the rotor, and no torque is generated. So the NR maximum value is lower than NS. Okay, so simply when the rotor reaches the speed of NS, both of them, of course it will not reach NS, both of them will appear stationary to each other. They will appear as if they are on a stator, for example. So no voltage will induced. Why? Because the voltage depends on d phi over dt. Okay, but when both of them are rotating with the same speed, both of them will appear, or the rotor will appear stationary for ns. So the d phi by dt will be equal to 0, so no EMF will be produced. So in this video we discussed the importance, construction and theory of operation of the induction motor.